So today on this episode, a bunch of you had asked about like an overview on the Berco and what's the difference between the Berco and the VanNorman. So we're gonna talk about that. We got a Lunati cam in the grinder, a little solid roller for a forward that we're gonna talk about, and then we got a little A model flat tappet for a land speed car we're going to talk about. So hang loose and we'll get into it. All right, so a couple of major differences between the two grinders. Number one, this one has a hydraulic system. This one does not have a hydraulic system. So the biggest deal is the whole wheel head will go in and out hydraulically, which is ultimately useless, because when the wheel head's in and you're grinding, we rock the table back. So, you know, the table's in when you're grinding, and then when you finish that lobe, you rock the table back, and then you move to the next lobe. So you never have to move the wheel head anyway. So that being hydraulic is just null and void to me. One thing, the reason it's that way more than likely is because all of their crank grinders is that way, and you need that feature in a crank grinder to move the head back out of the way of the counterweights. So that's probably why they done it that way. The other real nice feature is it's got a hydraulic dresser for the rock. So it's got a hydraulic cylinder, and it's got a little thumb screw here to adjust the speed which it travels across the rock. So we can dress it fast to rough the stone in, dress it slow to make the finish pass. So that's really nice. One other thing that it does have is the table traverse. So we've got this speed, and then it's got a little gearbox, and then we've got this super fine speed. And so what that does is sometimes we have to grind journals, like if we make a raw cam from bar stock, or a journal is hurt and we need to turn it down 10 thousandths or 20 thousandths, whatever it takes. Or for instance, if we had a 55 millimeter core and we could turn it down, or a 50 millimeter big block, turn it down to a standard big block, stuff like that and so you need, sometimes the journal is wider than the rock, therefore you can plunge, but you need to sweep back and forth because, the just cost of the wheel size. So that 2-speed bed is a really nice feature. Another question that people were asking is about the tooling. So all of the tooling is the same on either machine. The reason why is essentially this machine is a copy of this machine. So way back in the day, Harvey Crane sent a VanNorman to Berco in Italy, and they converted a crankshaft grinder to a camshaft grinder. That was the first iteration. And then once they had the system figured out, then they made castings and made, a machine, a purpose-built machine. So that's why ultimately, if you look at this machine and you look at this machine, it's very similar, because like I say, it's a copy of the VanNorman. And at the time when Harvey done that, VanNorman had stopped producing a cam grinder years ago. And I never did. I actually called VanNorman about some blueprints and stuff for these things, and they had no, obviously the people there now have no idea about any of this stuff. They even never seen a cam grinder. So they didn't have any idea about why they stopped or anything, but I just assume it was a supply and demand thing. Just, ain't a ton of people buying cam grinders. So anyway, hydraulics, the dresser, This thing does have like a auto lube system, kind of like a milling machine. So that's nice. One super nice feature that it has that the VanNorman doesn't have, but we can add it, is this thing has a 2-speed gearbox, so it's just high-low. But it's got a DC, over here it's got a DC gearbox, and here we have a speed pot, so we can adjust the speed from absolutely stopped to pretty fast. I don't remember what that max RPM is, but it's faster than you'd ever use. So that's a definite plus that the VanNorman doesn't have. The VanNorman has a 4-speed, so it's actually got a 4-speed gearbox to select different speeds and stuff. The other thing that I don't like, I like all of the things about this grinder except this. And the thing that I don't like is the way they done the dividing head. We call this the dividing head, and over here's the index plate. The way they did the dividing head is just stupid. So back here we've got, so this part back here is fixed to the spindle. So this always is in time with the spindle. So we've got 0 and +10 and -10 on either side of 0. And then the movable side, which is how we split the LSA, is 0, 360 degrees all the way around, which is silly because if you look at the VanNorman is back here on the fixed head, 0 to 10, 0 to 10, just like normal. But if you come around on the movable head, we got 0, 10, 20, 30, 40, all the way to 180, and then we got 10, 20, 30, 40, all the way to 180. So the reason that matters is when you split the lobe separation on any camshaft that turns clockwise, you're always gonna go this direction, this way. So the way the Berco is it's 360, so you have to minus the lobe separation from 360 to come up with the number you need to move to. And it's just not, you know, it's counterintuitive to do it that way. If it had been done like this, it would have just been, so I'm gonna make a new center plate and we're just gonna put it like the VanNorman and make it make more sense. The other problem is, let's go back to the Berco. So the other problem is on the front head here, we've got one scribe line for 0. On the VanNorman, we've got 0, +10, and -10. So this is how we determine the intake center line. So we've got all these different drivers. If you've seen, let's just look at this so because they may not have seen the other videos. So we make a scribe line on all our drivers. And then we know that that scribe line lined up with 0 equals a given intake center line. So like on this 351 Cleveland 400, the intake center line is 100 if this line is lined up with 0. So what we can do is, because the cam is half speed, so if we moved it, this cam needs to be, what is this cam? I don't even remember. The cam we did before this one, this is a regrind, so I think the intake center line is 102. So we need to move one line. So one line here is 2 lines at the crank, or 2 degrees at the crank. And so we don't have all the other divisions, so we have to just line up with 0, and then we have to do it all over here where we do the lobe separation. Where are you at? So we would have to move it here or there, depending on which way, and then we got to keep up with that dimension plus the LSA. So depending on which side of 0, it's either you got to add it or subtract it from the lobe separation. So it just makes it more complicated, and it's a lot easier to make a mistake depending on which way you got to go and if you went the right way and all that jazz. So I'm just going to make another center plate, and then I'm going to add the the 10 degrees either way on this plate to just alleviate all of those problems and just make it so much simpler. So that is what I don't like. And another thing, the tailstock is spring loaded, so it has this handle, we can just pull it and the tailstock retracts and we can pull the cam out. And so all the time it has spring tension on the center, whereas on the VanNorman, it's like an engine lathe. We have to, you know, pull it up and then tighten it to stop it from moving. And then as it laps in and wears a little bit, the cam can get loose. So you're constantly having to check the tension on the tailstock, so that's a little aggravating. It didn't come that way, but they did add, the people we got it from, they added a frequency drive for the spindle, so you can change the spindle RPM easily, and you can't do that on these. But again, that's something we can add. The other real innovative deal that separates the Berco from everything else is the head actually pivots. And the reason it needs to pivot is because if you do any flat tappet cams, they're all tapered. And a lot of people don't know this. So a Chevrolet GM flat tappet cams, all the tapers are one way, so it pushes the cam to the back of the engine. On Fords and Chryslers, the taper is two directions. So like the way this cam's laid out, it's intake, 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 and then it's exhaust, 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 exhaust. So the way it works is this lobe would be tapered this way, and the second intake lobe would be tapered this way, so they'd be looking at one another. And the two exhausts are the same way, they would be looking at one another. And that pattern carries all the way down the cam. So with the VanNorman, the way it works is the dresser actually tilts on an angle either way to dress the taper into the rock. So when you're going down the cam trying to grind that pattern, so we're gonna do all the intakes and then we're gonna do all the exhaust. With this grinder, you can do the first intake with the head tilted one way, grind that lobe, move to here, tilt the head the other way, grind that one, and just keep that up all the way down the line. And then come back and do the exhaust the same way, just like we would normally grind a roller cam, a flat cam. You're not changing the pattern. But with this machine, because the head doesn't tilt, we have to, you know, if you had this cam in this machine, we would have to grind all the lobes tapered the same direction. So we would grind half the intakes and half the exhaust. And then we would taper the wheel the other way and then grind the other half of the intakes and the other half of the exhaust. So it takes twice as long. It's inefficient because we're eating up the wheel for just, you know, and again, I mean, I guess they just didn't think that far ahead, or maybe back then it didn't matter time and money like it does today, but it's just a horrible system. It works fine. It's just a time-consuming system, and it's aggravating, and I don't like it, but it is what it is. So that is the downfall. But again, all I do is, well, we do some billet flat tappets, but very, very few. So mainly we do rollers, and we don't have to deal with taper. It's not a big deal. And there's, you know, once, I mean, we still want to make sure the lobe's straight, so we have to adjust the dresser to get the lobe parallel. So once we get it parallel, we got an indicator and we set 0 and we know that's parallel, and you know, and that takes care of that problem. The other, I think, maybe a couple of things that set this grinder apart from this grinder is this one weighs about 6,500 pounds. This one weighs 3,500 pounds. So there's a lot more iron in this grinder, plus it's just beefier and more robust. Everything about it is more robust. So it's just more rigid and you can grind faster. This one has more spindle horsepower than this one. And I mean, we can make that be the same, but it just isn't that way from the factory. So I can just grind a lot faster with this machine than I can this machine. But generally speaking, we're not in a speed contest. We're not trying to mow it off anyway, so it's not a major deal, but I can tell on, you know, a new billet, I can do a cam in this machine in 45 minutes to an hour, and this machine is an hour to an hour 20, just depending on the core and how much material we had to take off and that kind of stuff. But this one's for sure a little faster. But like I say, you know, all of the tooling, this is just a metric version of this machine. So the index plates are the same. They made the bores, like it's 2 and 750 on that one and it's 2 and 750 on this one. They didn't make it a metric version. Some stuff they did make a metric version, but the parts that interchange are the same. So that makes life easy as far as we don't have to make, you know, too different of everything. And what we have run into now, because we got two machines running, is a lot of times, not often, but I might be doing small block Chevrolets here and Andrew's doing small block Chevrolets there, and we don't have enough drivers, you know, the cam driver. So I've got to make more of these. We've got two of a lot of index plates, but we don't have obviously two of the same lobes. We don't have two of all the index plates. We don't have two of the drivers. So we're going to have to sit down and make a bunch of that stuff, especially the common stuff like small block Chevrolet, big block Chevrolet, small block Ford, because, you know, some stuff is the same. A small block Ford and a Cleveland is the same driver, and a small block or a LS and a step nose small block and a step nose big block are the same driver. So those that are really common, we're for sure gonna have to make two of them. It's just a no-brainer. But, you know, like universal plates, 45-degree plates, 30-degree plates, 60-degree plates, we've got two of that kind of stuff. We got two small block Chevrolet plates. We got so some other junk. We've got a couple of the same plates, but, you know, you're not super common. We don't have two. So, you know, some of that stuff we probably gonna have to make some extra of anyway. So let's talk about this little forward cam while we got it right here in the grinder. So this is this is a B model cam, but an A and a B is essentially the same cam, other than a B's got a fuel pump lobe, as far as I know. This one is for a land speed car. We'll probably do a whole video on actually grinding it or regrinding it. This is a factory core, and we're going to put some of our new direct action lobes on it. They have set a record, but they trying to do a little better on that record, so they want to try a different cam. And we talked about some specs, and I give them some options, and they made a choice. And so we're going to regrind this cam with some of our new lobes, and hopefully that's going to do what they want to do. We got a little Lunati solid roller over here that the lobes were a little fast, and it beat up some of the, have I done ground all the ugly? Yeah, on the opening side, you can see some deformation on the, and it had a real bad intake. This intake right here was really tore up, and I've already ground all the intakes. One thing that I run into, and I ain't seen this before, so I set up the exhaust were just minimally wore right on the opening side, right at the peak acceleration area. So I just cleaned up the first lobe and set the stop at 5 more to take 5 more off of it just to make sure we'd clean up all the rest of them. And so I got this one done, and I come to this one and went to 0 and it didn't even touch. So I was like, well, man, something's going on there. So I measured some more, and these 2 lobes on this cam, and again, this cam ain't never been touched. The guy bought it brand new. He's got all the paperwork he sent with it. We done, let's see here. And keep in mind, well, let me measure one that ain't been ground. I need my glasses. Is that 600? I think that's 600. Yep, 600. All right, so that lobe right there measures 1 in 600 tall. So this one right here, and again, I ain't took anything off of it. It's still just like it run in the car. And so this untouched lobe is 1 in 600, and this lobe is untouched. And I mean, you can see it shakes around. And so that is 55. Let me make sure. Nope, that's 80. Can't see. So this one measures 580 and this one measures 600. Let me see what this front one measures. Yeah, and that's 615. So this one measures 1 in 615. This one measures 1 in 600, and this one measures, what'd I say, 580? 580. So, I mean, I've seen some off, but I ain't never seen none that far off. And then these down here is what I've already ground that cleaned up. And I mean, I took about 10 thousandths off, and that's 85. And I've already took 10 off. So this one is smaller than this one, and I've already ground it. So I'm gonna have to come back on this smallest one and clean it up and set the stop at this dimension. But that's crazy, you know, I mean, again, 2 or 3 thousandths, 4 or 5 thousandths ain't the end of the world. I mean, they all should check. And if you've got different lifts on different lobes, you know, like intake to exhaust, the intake and the exhaust is not going to measure the same, or they shouldn't. But on all the intakes and all the exhaust should measure the same height within, I mean, there's really no reason why they should be more than a couple of thousandths difference. So for sure, and again, I can only guess, but to have that much difference, I mean, somebody just missed a stop and just went on, and or the core they were using, a lobe, you know, didn't clean up and they just went on. Or possibly, I've seen it, I guess, inexperienced grinders. Like right here, we got the steady rest, and this is pushing on that cam. And you can actually just tighten that up and it'll push that cam towards the rock. I mean, it'll bend it. You wouldn't think that cam would bend that easy, but you can actually stick an indicator on it. Watch that indicator. So, I mean, you can tighten it up enough that it's bending that cam in to the wheel, and it'll make all of these lobes right here in the center smaller than the rest of them because it's bending the cam in toward the wheel. But I don't think that's what happened. I think they just, either it didn't clean up and they just went on and called it a day, but they should have come back. And what we try to do always, well, no, we don't try, we do, you know, and it's happened sometimes, because the cores are lobe milled. So they're rough. And when we get ready to grind them, you know, we'll pick up on the first one and figure our heel to toe dimension from the journal size, and then we set it at that. And sometimes, not always, but sometimes you will end up with 1 or 2 lobes that you can just still see a little place, you know, where the lobe mill, you know, just whatever, it dug in or something, and it won't be bad, but it'll just be a little nick or a shadow or something. And so the only choice you got is to go back, start over, and take another 5 or 10 thousandths. And so the heel to toe dimension that you wanted, you may be 5 or 10 thousandths under that, but it's not detrimental. It's just that for the customer, measuring for push rods and doing rocker geometry stuff, all of those need to be the same, or he's gonna need, I mean, that's enough, you know, 20, 30 thousandths. Well, actually, that's 35 thousandths from here to here is 35 thousandths difference. And that's more than enough to make push rod length. You would have to have multiple length push rods to make all that work out. So, you know, it's just a FYI. Again, I don't see this often, and, you know, this could have been one of them ground on the last week before Lunati folded up and went out of business. I don't know, but I hadn't seen one like this, but that's bad. I mean, 35 thousandths difference, that's a lot. But again, we're gonna tune it all up and it's gonna be all good, but I just, that's the first one I've seen like that. So hopefully that answered, did I touch all the bases, Andrew? Hopefully this is the 3rd time we've made this video. We've had some kind of camera problem or audio problem, and I hope the 3rd time is gonna be the charm, I hope. So anyway, if you got more questions, ask them in the comments, let me know. And like I say, we're gonna probably, I gotta talk to the customer. I don't think it's gonna be no problem, but we'll see if we can get some pictures. He sent me some pictures of the car. I'll see if I can get some more pictures if he wants to share that stuff. And I'll show you all that on this flathead deal when we get ready to grind it. I think it'll be kind of neat. So stay with us, and we appreciate you. Check out the website, powellmachineinc.com, and we'll see you on the next one. Thank you.